The models are not disagreeing anymore. Both the GFS and the European have now locked onto the same picture, and if you live anywhere along the Gulf Coast from Texas to Florida, you need to hear what they are showing right now. This is not a routine summer outlook. What is setting up across the Atlantic Basin, the Gulf of Mexico, and the continental United States is a collision of factors I have not seen lined up this way in years. We are talking about near-record warm water in the Gulf running more than 1 degree Celsius, above the 1991 to 2020 average. We are talking about a loop current that just shed a warm core ring and is already regrowing, pushing warm Caribbean water northward right as we enter peak season. We are talking about a jet stream pattern that forecasters are calling one of the strongest Pacific jet extensions seen in June in years. And we are talking about an El Niño event that is now trending toward what climate scientists are calling a Super El Niño, arriving faster and building more powerfully than any of the major forecast models predicted when they issued their outlooks 6 months ago. The data from the last 2 weeks specifically has shifted the consensus dramatically upward. America's most dangerous summer in years is not coming. It is already beginning. Today, I'm going to break down the active severe weather threat hammering the plains and Midwest right now, walk you through a day-by-day look at the next 7 days, explain the massive pattern change building for mid-June and beyond, and then I want to tell you about the one thing happening in the Gulf right now that should have every coastal resident paying very close attention, because most channels are skipping right past it. Let's get into the data. My name is Arthur and you are watching Sky Space Lab, the channel where we do not simplify the science, we break it down. We use real data from real institutions, NOAA, NASA, the National Hurricane Center, the Storm Prediction Center, and peer-reviewed research. No guessing. No speculation dressed up as certainty. Just the science, explained clearly. If you are new here, hit that subscribe button right now. This is exactly the kind of week you want this channel in your feed. We're updating this coverage every day as new model runs come in, and before I go any further, if you're watching from anywhere in the Central Plains, the Midwest, the Gulf Coast, or the Southeast, I want to hear from you in the comments right now. Tell me your city. Tell me what is happening outside your window today. Tell me whether the storms have already reached you, whether you felt the first heat of the season building, and whether you have started thinking seriously about hurricane or severe weather preparedness. Your real-time reports add something no model run can match. Actual ground truth from actual locations across the country. That is not a throwaway line. I read every comment and I mean it. Your observations shape how I approach this coverage every single day. Let's get into the data. Right now, as of this morning, the Storm Prediction Center has active severe weather outlooks, covering a swath of the country, stretching from the Dakotas south through Nebraska and into the Texas Panhandle. If you are in this corridor today, here is who needs to watch this the most. In central and western South Dakota, particularly near Rapid City and spreading east toward Aberdeen and Mobridge, we are looking at a level 2 out of 5 slight risk for severe weather. But inside that slight risk zone, there is a hatched area for significant tornadoes. That means the Storm Prediction Center is not ruling out EF2 or stronger. The significant tornado parameter for this afternoon is showing values between 2 and 3 across central South Dakota. That number matters. When that parameter climbs above 1, you are in the zone where strong long-track tornadoes become possible. Values of 2 and 3 are not marginal. They represent an elevated threat that we take seriously on this channel. The atmospheric setup is textbook for this region right now. A low-pressure system is rotating over Saskatchewan, sending energy spokes down through the northern plains. The jet stream is threading through in a way that concentrates wind shear at the exact altitude levels where storms organize and tilt. Discrete supercells are expected to fire between 2 and 5 in the afternoon, local time near the Buffalo and Lemon areas of South Dakota. If even 1 or 2 of those supercells hold together before the line merges, we could be talking about a significant tornado threat between 3 and 7 in the afternoon. Here is the timing you need to know. The most dangerous window today is between 2 and 7 in the afternoon across western and central South Dakota. After 7, those storms are expected to organize into a linear segment, which means the tornado threat drops, but the wind threat increases dramatically. We could see 60 to 70 mile-per-hour wind gusts as that line sweeps east through the evening hours. This line will push into eastern South Dakota, southeastern North Dakota, and eventually reach parts of southwestern Minnesota through the overnight hours. It could hold together as a mesoscale convective system, an organized wind threat, well into the night. If you're in Fargo, Sioux Falls, Aberdeen, or Bismarck right now, I want to know what this looks like from your side. Drop your city in the comments below and tell me when those storms arrive. Are you seeing wall clouds? Any rotation visible? Your ground level observations help everyone following along on this channel and give us a clearer picture than any model run can. Further south, along the Texas Panhandle from Amarillo east toward Lubbock and Childress, there is a marginal risk for large hail with thunderstorms developing in the afternoon. Instability values are expected to exceed 3,000 joules per kilogram of CAPE in that corridor, and with a thin cap in place, any storm that fires and organizes could produce severe hail quickly. The main concern is golf ball to baseball size hail, 2 inches in diameter or larger. If you are in the Panhandle today, protect your vehicles and be ready for rapidly deteriorating conditions in the mid-afternoon. Across the southeast, from Mississippi through Alabama and into northern Georgia, there is a marginal risk area in place. The concern here is primarily wind gusts and heavy rain, but an isolated tornado or two cannot be ruled out in the Birmingham to Atlanta corridor. This is a secondary threat. The primary focus today is in the northern plains, but if you are in that region, keep your weather alerts active throughout the afternoon and evening. Tomorrow, Thursday, June 5th, the threat continues. The Storm Prediction Center maintains a slight risk across the Dakotas and into Minnesota. The upper low is still in place over southern Canada, sending another wave of energy through the flow. Storms should fire again by early afternoon near Rapid City, and this time the most focused corridor shifts slightly towards southeastern South Dakota, northeastern Nebraska, and areas near Sioux Falls. I expect tomorrow's storms to upscale faster into a linear mode, which would compress the tornado window but broaden the wind threat significantly. Still, any discrete supercell that holds together tomorrow afternoon carries real tornado potential. For those in southwestern Minnesota, you're going to be watching storm activity arrive during the overnight hours, Tuesday into Wednesday. Be ready for that. Set your phone alerts before you go to sleep. Now let me take you through the full week ahead, because this is where the picture becomes genuinely fascinating and a little alarming. Friday, June 6th. This is the day I've been watching most carefully. The low-pressure system responsible for the Northern Plains activity finally begins tracking east, and as it does, it opens the door for severe weather to spread into areas that have been quiet for weeks. The Midwest corridor, specifically Iowa, Nebraska, and parts of Illinois and Indiana, is going to see its first real severe weather signal in weeks on Friday. We have had almost no organized severe weather across Indiana or the Ohio Valley for the entire month of May. When the atmospheric tension releases into a region that has been quiet, the first round of storms can catch people off guard. Right now for Friday I am watching a broad area from the Central Plains through the Midwest for at least scattered severe thunderstorm potential. The main threats will be large hail and damaging wind gusts. The tornado risk on Friday is currently assessed as low. It depends on how organized the low-pressure system stays and whether discrete supercells can hold together ahead of the line. That picture will clarify in the next 48 hours, Saturday, June 7th. The low crosses the Great Lakes and pulls severe weather threat into Indiana, Ohio, and Michigan. These are states that saw almost no tornado warnings in all of May. The instability values will not match what we are seeing today in South Dakota, but with a fresh air mass and a deepening surface low pressing through, organized severe storms from Indianapolis east toward Columbus and into the Detroit area are possible. If you are in the Great Lakes region, do not let the quiet May lull you into thinking severe weather is not your concern this season. Saturday is a day to stay weather aware. Sunday, June 8th, remains uncertain. The European and GFS are showing different evolutions of the storm system across the Midwest and Northeast. I will not commit to a detailed forecast yet. What I will say is that storm activity increases across the Northeast by Sunday, and any break between Saturday and Monday is likely to be brief. Monday and Tuesday, June 9th and 10th. This is when it gets serious again. A new trough drops out of the Pacific Northwest. Southwesterly flow cranks back up across Texas, Oklahoma, and Kansas, and the renewed storm track brings the Dakotas, Nebraska, Iowa, and Illinois back into severe weather territory, and multiple extended range ensemble systems are now agreeing that the June 10th through 15th window carries elevated outbreak potential across the Midwest and Central Plains. That is a specific model-supported signal that I take seriously. Here is where it gets really interesting, and I will show you exactly why in just a moment. Because this is not just a weather week. It is the opening act of a pattern that is going to define this entire summer. And understanding what is driving it changes how you think about everything else I am about to tell you. Let me step back now and explain the big picture. Because what is driving all of this is not just a single storm system or a random wave of energy in the jet stream. This is a pattern change that affects the entire summer, and it connects directly to something enormous happening right now in the tropical Pacific Ocean. For the past several months, we have been locked in what meteorologists call an omega block. A high-pressure ridge has been anchored over the southern plains, creating a pattern where storm systems tracked in a somewhat predictable corridor through the northern plains, while the eastern two-thirds of the country stayed relatively quiet. That omega block is now breaking down. What is replacing it is being driven by a remarkable chain of events in the Pacific. Typhoon Jenmi made headlines this week east of Japan, but what most viewers do not realize is that Typhoon Jenmi is not just a Western Pacific storm story. It is a forcing mechanism for what is called a Pacific jet extension. When powerful typhoons recurve northward toward the Pacific in early June, they inject energy into the mid-latitude flow in a way that reorganizes the jet stream across the entire northern hemisphere. The jet extension lining up right now is one that multiple forecasters are flagging as exceptionally strong for this time of year. Here is what that jet extension does to the weather pattern in the United States. As we move past this coming weekend, a large upper-level ridge builds over western Canada and Alaska, what meteorologists call an Alaskan ridge. That ridge is driven by the negative Eastern Pacific Oscillation, or EPO, which the data shows transitioning from positive to negative around mid-June and staying negative through the middle of July. When the EPO goes negative, that Alaskan ridge becomes the dominant pressure feature, and it restructures everything else downstream. On one side of the ridge, temperatures build aggressively. The western United States, California, Nevada, Arizona, the desert Southwest, and the Pacific Northwest is going to see heat anomalies of 4 to 6 degrees above normal or more as we move into late June. This is the origin of the heat dome pattern that the extended models have been suggesting for weeks. For those of you in the West, air conditioning bills are going to be a real story this summer. On the other side of the ridge, the storm track dips southward and eastward. The northern jet stream stays anchored near the Great Lakes corridor. The subtropical jet, energized by El Nino, pushes northward from the Gulf and feeds moisture into the central and eastern United States. Where these two flows intersect, you get the conditions for repeated rounds of severe weather. Instability, shear, and lift all coming together in the plains and Midwest for weeks at a time. The data backs this up from multiple independent sources. The NOAA Climate Prediction Center's June outlook shows above normal temperatures favored across the western United States, the plains, the Mississippi Valley, the Ohio Valley, and the Southeast. AccuWeather's summer forecast explicitly calls for severe weather to be most active in June and July from the plains to the Midwest and Ohio Valley. Severe Weather Europe's long-range analysis, which has been tracking the Super El Niño signal, shows a precipitation corridor of above normal rainfall extending from the southwestern United States through the central and northeastern parts of the country. And the flooding zone that AccuWeather is highlighting most closely runs from Texas through the Ohio Valley, the exact area that saw some of the most heartbreaking flash flooding events in recent years. Most channels are not showing you this part, but it matters enormously. El Niño does not just affect the tropics, it rewires the entire global jet stream, and the El Niño we are dealing with right now is not a routine event. The Nino 3.4 index is already approaching +1. That is the threshold for moderate El Niño. But the subsurface ocean temperature anomalies in the tropical Pacific right now are extraordinary. Research from Severe Weather Europe published just last week shows that latest forecast data reveals a faster than expected transition towards Super El Niño status, an event that, if confirmed, would rank among the most powerful ever recorded. Super El Niño summers historically produce specific atmospheric signatures that we are already beginning to detect. More rainfall across the central and northeastern United States, more active storm tracks from the plains into the Great Lakes, a strengthened subtropical jet that keeps tropical moisture flowing persistently northward from the Gulf. Below or near normal temperatures across the Midwest and eastern United States compared to the broader warming trend. Not because it is cool, but because storm frequency keeps conditions from building heat. I've been doing this long enough to know when the pattern pieces are lining up in an unusual way. What I am seeing right now, the jet extension, the ridge building, the El Nino trajectory and the Gulf temperatures, is one of the most cohesive atmospheric setups for an active severe weather summer I have tracked in years. If you are in Iowa, Illinois, Indiana, Wisconsin, Michigan, or the Eastern Plains states, the second week of June is just the beginning. This pattern does not end after 1 week. It builds through July. And there is one more dimension to this that I cannot gloss over. As all of this severe weather potential builds, the National Weather Service is heading into this summer with staffing that is not where it should be. Reports from earlier this year confirmed that 30 weather forecast offices were operating without a meteorologist in charge. Multiple field offices had cut back or halted weather balloon launches entirely. Those balloon launches are how we collect vertical atmospheric data that feeds directly into the models every one of you relies on. NOAA lost its contract for ocean surface drones that gather data inside developing hurricanes. As retired National Hurricane Center chief forecaster James Franklin wrote publicly this past year, the warning and forecasting enterprise is experiencing what he described as a death by 1,000 cuts. In a summer that looks like this one, that gap between what the atmosphere is capable of and our institutional capacity to warn people about it is not something this channel will stay silent about. Before we wrap up, there is one more thing you need to know, and this is the part I've been building toward this entire video. The Gulf of Mexico is not just warm right now. It is at near record levels for this time of year, and the way it got there and the structure of that warmth has enormous implications for this hurricane season. As of the most recent oceanographic data available, Gulf of Mexico sea surface temperatures are tied with the same date in 2024 as the warmest on record, running more than 1 degree Celsius above the 1991 to 2020 average. But here is the critical detail that most people miss when they see that number. 1 degree Celsius above average is not just about the surface. Research from the University of Miami and multiple NOAA laboratories confirms that Gulf warm water now extends to depths of 100 meters or more in the eastern Gulf. That depth of warmth fundamentally changes how a hurricane behaves when it moves over the Gulf. Let me explain exactly why this matters. When a hurricane moves over shallow warm water, its own rotating winds churn up cold water from below, cooling the surface and effectively putting a brake on the storm's intensification. Meteorologists call this cold upwelling. It is one of the natural limiting mechanisms that prevented Gulf storms from intensifying too rapidly in earlier decades. But when warm water extends deep below the surface, the hurricane's winds simply stir up more warm water. There is no cold break. The storm feeds on a continuous fuel source all the way to the bottom of the warm layer. This is the mechanism that fueled Hurricane Helene's shocking intensification as it approached Florida in 2024. Yale Climate Connections published a detailed analysis just weeks ago that I want you to understand clearly. Since 2012, the Gulf's summertime sea surface temperatures have risen at roughly double the pace of global ocean warming. Record highs were set in both 2024 and 2025. Near-record warmth is persisting into 2026. The science shows that Gulf warming by approximately 0.5 degree Celsius per decade, which is the documented rate, already adds roughly 3% per decade to peak wind speeds in the strongest storms. That compounding effect is already measurable. It is not theoretical. The loop current is the delivery system for this heat. It flows out of the Caribbean through the Yucatan Channel, curves through the eastern Gulf like a horseshoe bending toward the Florida Keys, then exits through the Florida Straits to join the Gulf Stream. Every year, the loop current sheds warm core eddies, spinning rings of warm water that break off and drift into the central Gulf. In February of this year, the loop current shed one of those rings. That ring is now drifting westward toward the central Gulf. And, this is the part I want you to pay close attention to, the loop current is now in a regrowth phase. It is extending northward again right now. It is actively transporting warm Caribbean water deeper into the Gulf Basin as we speak. When the loop current is in regrowth mode, it is in the configuration that most favors releasing another eddy during the peak of hurricane season. Peer-reviewed research published earlier this year is explicit on this. New analysis flagged just this spring confirms that this specific loop current configuration increases the odds of rapid intensification for any storm that crosses it during peak season. Peak season is August, September, October, the months when the most powerful storms historically have formed. The loop current is setting the table right now, today, in early June. By the time peak season arrives, this setup will have had months to deepen further. NOAA's official 2026 Atlantic hurricane season outlook calls for 8 to 14 named storms, 3 to 6 hurricanes, and 1 to 3 major hurricanes. The agency places a 55% probability on a below-normal season. Colorado State University came in with a similar call: 13 named storms, 6 hurricanes, 2 major hurricanes. Both are driven by El Nino, which typically raises wind shear across the Atlantic main development region, making it harder for tropical systems to organize and intensify in the open ocean. But here is what I need you to understand precisely, because the statistics can be misleading in a dangerous way. Below normal does not mean low impact. NOAA Administrator Neil Jacobs said it plainly at the May 21st Outlook briefing. It only takes one. There have been Category 5 storms making landfall during below-normal Atlantic seasons before, and what makes this particular below-normal forecast especially worth scrutinizing is where the activity is most likely to actually occur. El Nino shear suppresses development most strongly across the deep Atlantic, the main development region stretching from the Lesser Antilles to the African coast. That is where the bulk of Atlantic storms typically form. El Nino makes that region hostile to tropical development. But the Gulf of Mexico and Western Caribbean operate under different rules. A disturbance forming in the Bay of Campeche, a tropical wave crossing Central America from the Pacific, a low-pressure system spinning up in the Western Caribbean. These systems can get into the Gulf and find an environment that is dramatically different from the suppressed open Atlantic. The Gulf right now has its own physics, and those physics currently favour intensification. Updated just within the last few days, both the GFS and European models have been showing a pattern at the 10 to 15-day range where energy from the Eastern Pacific crosses Central America and enters the Gulf. I want to be completely precise with you here. Anything at 10 to 15 days is far outside reliable forecast range. These are not forecasts, they are model signals. I am not predicting a Gulf hurricane. But the environment that those models are pointing a storm into, near record warm water, a loop current regrowing northward, diminishing shear during the right window, that environment is real, and it exists right now. Here is the statistic that should be pinned to the wall of every emergency management office on the Gulf Coast. 5 of the 10 continental United States landfalling storms that strengthened by at least 40 miles per hour in the 24 hours before landfall, 5 of those 10 have happened in the last 9 years. The era of rapid intensification in the Gulf is not an anomaly, it is the new baseline, and we are entering this hurricane season with Gulf temperatures and loop current structure that represent the most favourable rapid intensification setup we have seen in years. If you live in coastal Texas, Louisiana, Mississippi, Alabama, or Florida, I am talking to you now specifically. Houston, Galveston, New Orleans, Mobile, Pensacola, Panama City, Tampa, Sarasota, Naples, Fort Myers, the Keys. Does your hurricane plan account for a scenario where a storm goes from tropical storm to Category 3 or 4 in 36 hours? Because that scenario is not a worst-case outlier anymore. It is within the normal range of what the Gulf is capable of in the current oceanographic environment. Rapid intensification does not give you a week of warning. It can give you 24 to 48 hours, and the National Weather Service forecast offices responsible for those warnings are operating with fewer staff than they had a year ago. Drop a comment right now, Gulf Coast residents especially, and tell me your county, your evacuation zone if you know it, and whether you have your hurricane plan in place. I read every comment. This is not for engagement metrics. I genuinely want to know if the people who are most exposed to this risk are thinking about it. And if you're not sure about your evacuation zone or your county's emergency notification system, this week, not next month, is the time to find out. The first named storm of the 2026 Atlantic season will be Arthur. The list goes Arthur, Bertha, Cristobal, Dolly, Edward, and Faye. I genuinely hope we do not get far down that list. The below-normal seasonal outlook gives us reason for real optimism about the frequency of storms. But frequency and impact are not the same thing. One storm in the Gulf, one storm that finds that deep warm water, that crosses a loop current eddy at the wrong moment, that encounters a shear window that briefly relaxes, can redefine a season that the statistics called quiet. I am watching the Caribbean and the Bay of Campeche closely every single day as this pattern evolves. The models are hinting at something in that 10 to 15 day range. I am not chasing it, but I am not dismissing it either. And the moment that picture sharpens into something worth a dedicated update, you will see it on this channel first. This has been a dense video, and I want to bring it all together before I let you go. Right now, today, and tomorrow, the severe weather threat is real and focused across the northern plains. South Dakota especially, spreading into North Dakota, Nebraska, and parts of Minnesota. Tornadoes are on the table this afternoon. The significant tornado parameter is elevated. Know your shelter location. Have your plan ready before those afternoon storms develop. Through Friday, Saturday, and Sunday, that threat migrates east into the Midwest and Great Lakes. Iowa, Indiana, Ohio, and Michigan are all in the picture by this weekend. This is the first significant severe weather signal many of those areas have seen in weeks. The quiet May does not mean the season is quiet. It means the season is just getting started in your region. The second week of June, June 10th through 15th specifically, carries potentially elevated outbreak potential across the central and northern plains and the Midwest. Multiple ensemble systems are now aligned on this window. Watch it closely, every single day. The big picture is a summer being reshaped by a developing Super El Niño event, an Alaskan ridge pattern building through July, a storm track pushing repeatedly into the Midwest and Great Lakes, and a Gulf of Mexico carrying near-record heat into hurricane season, alongside a loop current configuration that maximizes rapid intensification potential for any storm that crosses it. If this video helped you understand what is actually happening in the atmosphere right now, not just today but the whole summer ahead, hit the like button and share it with someone you know on the Gulf Coast or in the storm corridor. That genuinely matters. The more people who understand the physical setup behind what is coming this summer, the better prepared communities will be. That is why this channel exists. Tomorrow I will have updated ensemble runs for the mid-June severe weather pattern and the latest read on any tropical signals developing in the Caribbean or Eastern Pacific. If anything changes overnight in the models, especially anything touching the Gulf, I will bring you a special update without waiting for the regular video. And now, the question I want to leave you with, and I genuinely want to see your answers in the comments below. Where are you watching from today, and what does the sky look like outside your window right now? Are you in the active weather corridor? Have you started your hurricane preparedness checklist if you're on the coast? Your answers are real data, observations from real locations across the country that ground this coverage in something more valuable than any single model run. Drop your city and your situation below. I will see you tomorrow.